Okay, in this video I want to take a look at problem number 30. We have the piecewise function f of x is equal to sine of x when x is less than 0, 1 minus cosine x when x is between 0 and pi, and cosine of x when x is greater than pi. Now it may be a while since you've graphed these functions, but they are basic functions that we should understand how to graph them from memory and using some simple function transformations when they're needed. So sine of x is going to look like, well, if we set up our tick marks to go from pi over 2 to pi to 3 pi over 2 to 2 pi, and then the regular 1, 2, or negative 1, negative 2 for the y values. So pi would look, if you recall that pi, we want to go to the left here. Pi of 0 is 0. But in this case, so we want values for x is less than 0, so we don't want to include 0 there. But after that, we're going to the left now for sine of negative pi over 2. Sine of negative pi over 2 is negative 1. Then sine of negative pi, which is the same as sine of pi, is 0. Sine of negative 3 pi over 2 is the same as sine of pi over 2, and that's 1. Sine of negative 2 pi is the same as sine of 2 pi, which is sine of 0, which is 0. Alright, so that should give us plenty of values to graph on the left side, to the left of the y-axis. And I'll just draw that oscillating graph in there. So this takes care of to the left of 0. Now, to the right, from 0 to pi, the function is going to look like 1 minus cosine of x. And then for greater than pi, it's going to look like cosine of x. So let's talk about at pi. Let's do the last branch, the third branch now. Cosine of pi is negative 1. But again, we don't include pi, so we want an open circle there. Then cosine of 3 pi over 2 is 0. Cosine of 2 pi is 1. And we're going to continue to get the same oscillating pattern there. It'll go back to 0 then after for 5, that would be 9 pi over 4. And we can draw that graph in now. Alright, and so that takes care of that part. Now what would 1 minus cosine of x look like? Well, cosine, normally, if I were to continue the one from greater than pi over to the left, it would look something like that blue section there. But first of all, we want negative cosine of x. Or we could rewrite 1 minus cosine of x as negative cosine of x plus 1. So to make that negative, we would flip that over the y-axis. And so we would get something like that. Then the next thing that we have to do is shift that up by 1. And so it would look something like that. Alright, so that basically does it for this function here. And we can see that limits are going to exist everywhere. We have the same behavior from the left and the right at 0, no problem. We have the same behavior from left and right at all the points in purple, all the points in green, all the points in blue, except at x equals pi, where we have differing behavior there. So we would write here that I'm just going to draw those little arrows on the purple side to the left and the green side to the right, showing that it goes on forever like that. So the intervals where limits exist will be from negative infinity up to pi, but not including pi, and then from pi up to positive infinity. Again, but not including pi or infinity. So that does it for problem number 30. And hopefully that gives some review of the basic trigonometric functions, what a sine curve, cosine curve looks like, and also how we perform some basic transformations on those functions in graphing. Alright, I'll go on to problems 31 and 32 in the next video.